will discuss here reflections about the x-axis. Suppose that the graph of the function g of x is given and we want the graph of the function f of x equals negative g of x. Now if the point AB was on the graph of function g of x, then the point A, negative b, is going to be on the graph of the function negative g of x. Since the points A, B and A, negative b are symmetric with respect to x-axis, the graphs of g of x and negative g of x are also going to be symmetric with respect to the x-axis. Therefore, to obtain the graph of negative g, we must reflect the graph of g about the x-axis. So let's look at the example. Suppose I want to sketch the graph of function f of x equal negative x cubed. I can think about this function as the function negative g of x, with g of x being x cubed. X cubed is one of the basic functions whose graph we should know and whose graph is actually drawn in the coordinate system. So function f of x is the reflection of the function g of x about the x-axis. So to get the points on the graph of f of x, we have to reflect points on the graph of g of x. For example, we have point negative 2, negative 8 on the graph of the function x cubed. This point reflected about the x-axis becomes point negative 2 and 8. X coordinate is the same, stays the same, y coordinate change to the opposite. Point negative 1, negative 1 reflected becomes the point negative 1, 1. 0, 0 when reflected becomes the point 0, 0. This point is on the axis of reflection, or axis of symmetry, so it doesn't change. Point 1, 1 becomes point 1 and negative 1. Point 2 and 8 becomes point 2 and negative 8. Now joining those points in the order that they were plotted gives us the graph of the function, and as you can see we have the symmetry with respect to x-axis. The red graph is the graph of function negative x cubed.